46, we've got this mass on a slope. It's got weight 3m. So the force coming down here is 3 mg. And because the slope is 30 degrees, here I've got 3 mg cos 30. And coming down here, I've got 3 mg sine 30. It's being pulled up the slope by a cable with some tension in it. There's going to be a normal reaction here, and there's going to be some friction here. They're telling us the coefficient of friction is 0.1. So I'm just going to put 0.1 R on there. So there's the bit on the slope. And the other bit is this freely hanging mass of 2m. So I've got 2 mg down, and I've got some tension up. And the whole thing is going to start moving with some acceleration here. And I think, right, just starting looking at the slope here, we can actually see the normal reaction. So R minus 3 mg cos 30 equals 0. There's no other forces there. So I know what R is. And because I know what R is, I then actually know what that friction is, don't I? So let's see what's pulling it up the slope. I've got tension. Take away this part of the weight, the 3 mg sine 30. And also take away this part of the force here, the 0.1 times the normal reaction, 3 mg cos 30. And that will equal the mass times acceleration. The mass of this is 3m times by a. Put all of that in there. Let's also do this part here. So going down at the other part, Q is 2 mg minus t equals the mass times the acceleration. Usual things, writing them all out. Going to add these two equations together because then the tensions will cancel out. And I'll get on this side here, I'll get 5 MAs here. And on this side, I'm going to get 2 mg. I hope I've left enough room from it. Take away the 3 mg sine 30 and take away, well, I've got 0.3 there, mg cos 30. No, I haven't left enough room. Notice that although they didn't tell you m, all the m's can now cancel. I've got an m there, and there, and there, and there. I can tap all of that into the calculator and divide by 5. And after all of that, I can find that my acceleration is 0.47 meters per second. Oh, I thought that was it. It doesn't. It says find the time taken for the speed to reach 10. So look, now I've got u is 0. V, we want it to reach 10. The acceleration we know is 0.47. Find out the time. Let's just use a v equals u plus at. And I'm getting a t there to be 21.2 seconds. 21.2 seconds. An assumption I've assumed it's not reached the pulley. I'm assumed the other one's not reached the ground. That's the sort of thing I'm going for there. And there's more. Let me read it. Okay, it's another one of these ones where it's snapping. So I'm actually going to rub this bit out, because if it's going to snap, the acceleration will have changed. So I'm going to go all the way back to here, And actually, if it's snapped, I don't care about that one either, do I? Going all the way back up to there. And if it's snapped, there's no tension left. So I can rub that T out there as well. And this is the equation I'm looking at. This equation here, because there's no tension, it's not being pulled up the slope anymore, here is how I can find my new acceleration. So all I can do is tap in all of this. I can, well, divide by m actually, can't I? There's no m's in all of that. I can, as I was saying, tap in all of that and divide by 3. I can find out that the new acceleration here is minus 5.7487. We're told it starts at 10 meters per second because that's when this thing breaks. We want to know how long till it, that should say u, how long it takes till it stops. So v is 0. and we want to know what S is, and there's that bit there. So if we use a v squared equals u squared plus 2as, got 0 equals 100 minus 2 lots of... Now have I got my things and my signs around the right way here? Let's just have a think. Yes, it's all okay. I was a bit lapsed, wasn't it, because it's so long into the question. This is going up, that's 0, and this, the acceleration in that direction is negative. So I've got minus there. So look, it's plus minus there. So what have I got? 100 divided by that. I'm getting that S here is equal to, I've got 8.7 meters there. Sorry if I've garbled that. Add that onto both sides and divide by it. The last part says, will it slip? Once it gets there, will it slip? So at that point there, when it's on the slope, what's pulling it down the slope all the way back up there is that thing there, isn't it? 3 mg sine 30. Well, we know sine 30 is a half, so a half mg. What's making it stop there is the friction. And the friction was 0.1 times by 3 mg cos 30. Well, let's ignore the m's, and you can see that this one is much bigger than this one here. And so because that one's bigger than that one, therefore it slips down. The force down is greater than the force up, so it must be slipping down.